Well, I'm having an evening of minor disappointment here in the lab, so I thought I'd share the moment for all who are interested. Just this week on eBay, I purchased this model of Excelsys power supplies, and the reason I was looking for them is because in my recent visit to the Living Computer Museum, I saw these in operation on some of the very old 60s and early 70s mainframe equipment, and even smaller things like the Data General Nova, and talked with some of the engineers, and they said we just rebuild them all with this, which is really very cool. They keep the original power supply in there, they just disconnect it and reconnect it with these. So I said, well, I'm going to be restoring a Data General Nova. I need a power supply, so let's start with one of those. And I found one that has an output, supposedly, of 15 volts, which is one of the, and I wasn't sure if it was positive or negative, but I thought I'd figure it out when I saw it, and it wasn't that expensive. It was being sold as untested. Untested, but cosmetically fine. So, that usually, roll the dice, don't go so bad with that, and it was under 50 bucks, so I thought, well, we're doing pretty well. Others are, in the hundreds. And I can see why. They're pretty quality things. Except, as it turns out, this untested one, well, it doesn't work. So, what I'm going to do is I'm just going to go through a quick overview of me putting this back together so that I can go play with it another time. And if anyone who sees this says, oh, wait, I know what's wrong, or you might want to check this, I welcome that. I absolutely welcome that. So, I'll just go through this here and see about putting this back together. So a little bit about the anatomy of this. You're looking at it now in pieces, but it's a design I've never seen before, but I'm not that experienced of, an electrical engineer. I'm not an electrical engineer. I might have been one day, but I never became one. Anyway, that's another story entirely. Sorry! So, this is supposedly the main universal power output, and this is arranged in such a way where this powers the configurable modules. And this particular model allowed slots up to 4 modules, and we had 2 slots available. Those 2 slots were configured for 15 volts, and then a 5 and a 24 apparently. So evidently this module was 15 volts only with some senses, I guess. And then this one was 5 volts, 10 amps upper, and 24 volts, 3 amps lower. And so evidently it's 3 volts on 3 different voltages on 2 modules, and space for 2 other modules. Now, it seems that this provides enough power to to connect to any configurable module. I can see why this is a preferable design, because you got one power supply and you can just insert the right module for the right voltages that you need, up to 4 different ones, or maybe more than 4 different ones, because evidently one module can have 2 different voltages on it if you believe the label here. But I have nothing to test. So here's what I did. I tore this thing apart, and I tested voltages. Of course, the fuse is fine, yes, no problem. It clearly says that it's good for 110 to 240 volts AC, and I'm working on, about 119 volts AC on my line right now. So, you figure that'd be all right. Well, evidently, this does some really fancy stuff. And according to one YouTube video from Excelsys, a smaller model of this provides plus or minus 180 volts. It doesn't say DC or AC, but if it's plus or minus, I assume that it's AC. And so, evidently, that's what this module does, is provide plus or minus 180 volts to these pins right here, only 2 of the 4 of them. And this is where it really gets interesting. It seems that there's no physical connection. We have this board right here, which appears to be just windings in 8 layers. See that there? We have layer 8, sorry, upside down. Layer 8, we flipped it over. Layer 1, right there. And then there's this, what looks like a, ferrite, very lightweight ferrite core thing here. And as you can see, that's really loose. And the only thing that's holding these two together is some silicone right here. And looking at these boards, I can see that we have one soldered in here and the other one soldered in down here, and it seems like we just have these four voltages. And there's these just wafer boards, which evidently just, work like coils, like transformer coils, except they're in printed circuit boards, which is kind of cool. I don't know if this is revolutionary or if this is just very, very, common in modern power supplies, and I've just never seen it because I haven't torn a whole lot of stuff apart. But to me, this is kind of wild and radical. So, anyway, but I'm absolutely getting nothing out of this port right here. Absolutely nothing. So, I imagine that something in this is dead. So, I spent about an hour testing some voltages, and let's just go here to the back. Definitely I have the 120 volts that come in. Got it as far as this. This appears to be a nice stout full wave bridge here, converting AC to DC, and it absolutely converts 119 volts AC, and we get a good 109 volts DC out of this. So evidently there's a little bit of voltage drop, but we're definitely going to get definitely getting 109 volts DC out of this. This big monstrous coil is good. There's just two connectors on it, one here, one here, and so I still get you follow that around to this thing. I get 108 or 109 volts DC all the way to here, and then there's probably a disc fuse capacitor thing like that. Right there. Forgive my terminology. That was highly technical, wasn't it? Disc fuse capacitor thing. Someone's making fun of me on that, I'm sure. Go ahead, make fun of me. I don't blame you. And I'm definitely getting, there's good connectivity across this, getting the voltage to there, and after that I just kind of got lost. I checked these connectors, and I think I'm still getting... let's check. I'm just going to plug it in. I forgot. But, I feel like I want to go through that. So here's my meter. Let's see here. Can I put that in so I can see it? Yeah, we can see that. That's good enough right there. Oh, what the glare. I hate the glare. Here. There we go. No glare there. All right, I'm going to plug this thing in. Give it some live voltage here. And it's definitely sucking some power, so it charged up capacitors and such, because I heard the amperage spark when I plugged in the cable over here. All right, we're set on volts DC. So let's start with, the output for the full wave bridge here. 106 volts, just to verify. Here we are on the AC side into the full wave bridge. We have 119.3 or 0.1. Go to line voltage there on AC. Voltage DC after the full wave bridge. 106. It's now polarized, so I had that backwards. This is the negative, this is the positive. There we go, 106. Alright, and so we should have 106 there as well, and we do. And we follow that around, we should have 106 here as well. And we do. And that's just where I got lost. Now, I did check this. We definitely got some voltages here on this thing. Yep, 100, and it stepped up. Now it's at 163, which makes me think that at least part of this is working. I guess bad connection there. Because if this one Excelsys video that I saw of Excelsys, and by the way, I should mention, Excelsys.com redirects to a website about some energy company, and the stuff that is on there is totally useless and seems completely unrelated to the power supplies that they used to make. So I had to go to archive.org/web, yes, the Wayback Machine, to look at their website from just a few years ago to be able to see what that looks like. And, you know, they still have videos on YouTube describing this. And that one video on YouTube that I'm going to link in the description below that actually talked about the operation of a smaller model here talks about the input here being a plus or minus, plus and minus 180 volts. Now, when I look at this, it's a DC signal here, I think. Come on. Let's try that. Yep, there's a negative there. That's a nice, solid thing. Obviously, I have it backwards, so that's the negative, that's the positive. 163. So we've stepped up in voltage, and we have a DC voltage there. And it looks like there's some interesting things going on here. So what the heck? 163 there. Let's check to that. That's nothing, so that probably means that those are connected. And nothing. See, so basically these 4 pins right here, sorry for the glare there, these 4 pins right there, I wonder if I need to change that. Light is great, glare sucks. Oh gosh. Here, this thing's live, so I'm going to be very careful here. Put it on something non-conductive. There we go. So, evidently, from what I can tell, only 2 of these 4 pins right here are what's supposed to be the high voltage that goes into this coil, right? And this wafer 8-layer wafer board coil, and only 2 of these 4 pins actually, you know, take the voltage. And I can see a connection to that one right there, the top, the one my finger's touching, and the other one. I see something on the back. Yeah, we see the one on the back right there. So evidently this winds through, this coil winds through 8 layers of board. And it's just, yeah, the caddy corner too. So that's it. It's just those 2 connectors going through that pin. That's supposed to be 180 volts. Clearly it's those 2 right there. And so when we check this, you see I'm getting pretty much nothing on this. It's all in the millivolts section, although it don't seem to have a pattern, right? And so I'm thinking, well, you know, maybe I'm looking at AC, so let's switch over to AC and see if we get anything there. And interesting, when I put it on this and just leave this one in the air, I'm getting 4 volts, so that says something. But then I do this and, you know, it nearly goes down to 0. So it's just so odd. Yeah, I don't know. So there's some magic that happens here. Obviously it's not magic, I just don't know what it is, so it seems like it's magic. That's supposed to be putting the voltage here that runs the whole thing, and I'm pretty sure that we just don't have it. So there's something wrong in here. And there's some power transistors here, and they could be power rectifiers. I'm going to, you know, put the camera on what I can see with them without completely disassembling this so that we can see them. But it's pretty obvious to me, given the size of these, the width of these lands here, that this is what conducts the power, right? These big ones. And so, and they're connected to these rectifiers or power transistors, not sure which they are. And that's supposed, I'm sure that they're responsible for rectifying and regulating the power that's supposed to be right here that I think isn't. So there you go. And so really the differential between these two, whatever that is, you know, maybe there's something wrong here, maybe there's something wrong in the controlling circuits, I don't know, but I'm just not really quite ready to tear it apart. But again, open to suggestions. So let me unplug this thing so I can touch it, And let's have a look at the other side here. Alrighty. So here's a heatsink. And there's this, let me arrange this here a little bit better. Thing off camera. There's these power transistors in there, or regulators, not sure what, but obviously it's a very nice, hefty heatsink. And some beautiful components there on this vertically mounted board. And a nice capacitor there, which certainly looks like it's in beautiful shape. Oh, and, you know, I did check the voltage across this. It is 160 some volts DC. And so, you know, I don't think that capacitor is objecting to anything. It's 240 microfarads, 400 volts. So this is one of those that has the 164 volts across it. Have a choke there. But anyway, let's see if we can see anything interesting from this side. More of those power transistors. We have some resistors and capacitors in there. Row of some serious diodes. Look at those serious diodes. I'm just now seeing those as I'm looking at this in the camera, because I couldn't see them with my eye. I wasn't looking at the right angle, but there's, you know, you see them there. There's these. See if I can hold this, and there. There's this big row that just goes back. Good 4 big, huge diodes. So, I guess they're here. Maybe I could be checking those here, here, and here. Huh. Oh, what the heck. Let's check the diodes. So I think, I mean, you know, we're here. The camera's rolling. Let's do it. Alrighty. Now, I don't have it plugged in. I just want to point to these before I do, because, you know, I'm touching what would be high voltage here. So don't try this at home, kids. Trained professionals only. Like I'm one. Ha ha. Okay. There's one there. I think there's one here, right? And those two are connected right there, and there's one there. So these are diodes. So I should get some interesting voltage there. Let's check them. See what I get. This is interesting. I don't know which direction they're facing because I can't really see them very well. But I'm on volts DC. So if I were to compare this to this, there's 106 volts again, which is basically what I got in the source. So there's 106 volts there. Okay. So, what about millivolts? (106 volts to that. Now that's in the millivolts range. So that's nothing. Yeah, there's nothing there. See, in here we're getting that strange oscillation again, the same that I do from here, these two. So these two transistors or rectifiers, whatever they are pretty obviously what's supposed to be providing this plus or minus 180 volts to this, and they're not doing their job. So either they're burnt out or something that tells them what to do is burnt out. So yeah, let's unplug this again. And, you know, I'm just getting it, just because the camera's rolling and I'm talking my way through this. That always helps the process. So, you know, thank you. You're helping me here by watching this. Gosh, you can't see what they are. Yeah, this heat sink, probably pretty stuck to the heat sink, but And I'm wondering, do I need to take the heatsink off? Well, I've taken it apart this far. Let's see. That all cemented in there. You know, here's the thing. I can't find a schematic for this thing anywhere online. Maybe I'm just not looking in the right place. Here, let's have a close-up on the board anyway. I looked that up, and we just didn't find a whole lot there. See the number there on the board, 62115. Oh, and I looked this one up as well, the number there. That's an Eton ET566, and I found other boards made by ETON, but certainly not this. But again, this just seems incredibly simple. And actually, you know what I haven't done? I haven't checked connectivity on this thing. Not that I expect it to be anything, but I'm just curious what the resistance is in this 8-board coil. It's probably very, very low. So I think we're checking this to this. Or is it this to this? I think that's it. Yeah. So we're getting half an ohm there. So that is definitely, you know, a pretty... That's pretty much a dead short right there. I mean, there's not a lot of resistance on that thing. But it seems to be the way it's designed. I mean, it's a coil and 8 layers of board. It's, you know, it's definitely unique, especially the way that flops in there with no connection whatsoever. That's isolation for you. Okay. So anyway, yeah, what the heck? Let me try to take this heatsink off. I probably won't be able to separate these properly. You know, maybe I'll change my mind. I change my mind a lot. Have you noticed? I changed my mind a lot. Yeah, those are stuck on there pretty well. I'm trying to see if those things separate easily. I don't think I want to take this thing off. Not now. I'm not ready for that level of surgery. I suppose that's the next logical thing to do. You know, just to see what they are, I'd have to take off this board. I don't think I can get a mirror in there and really see what they are. I really think I need to disassemble it, especially if, you know, one of them needs to be replaced. That's why I think it's the only way I'm going to figure out what they are is to, you know, disassemble this. So I just don't think I'm going to find a schematic. If you can find a schematic, please do. Please do. You know, I did find a on the Wayback Machine, archive.org/web. I did find the PDF manual for this, but it's only 4 pages. It shows me that, you know, 3G is the generation of this, 4B is the configuration, and 36, I think this is a 3, this is a 6, and this is a 0, and this is a 0. I think that's how they do this, and then there's other configurations in this number. So, you know, good luck with this, the 3G B4 3600K008. Even if we go to the 3G 4B, it's not B4, 3G 4B, actually, if you reverse those, you're going to find a YouTube video of someone who shows a similar power supply to this working, some firm in India showing a similar power supply to this working, but all it shows is their phone number and how to contact him. So I guess they're demonstrating that they fixed it, but they're absolutely giving no valuable information as to how. So that was kind of like, it's a tease. Okay, anyway, I digress. Let's just put this thing together, just so we can see how it goes together, because it is kind of an interesting chassis here. Here's the aluminum, and you know, it has these nice ridges in it, and I like how this just slid in place. So let me do that now. That bolt is what holds this in. So I'm just going to slide this in place, fit this in the lower track there. Just slides right in. See, I like that. It's a nice design. Very nice design. And there we go. Okay, that's in place. And so what's next? Well, these things that just kind of flop around. And I think there's, oh yes, there's this thing, little plastic slip that goes here, right over what looks like T1. See the T1 right there? Transformer 1. So that's a transformer, and it looks like a transformer. It's just the first time I ever saw a transformer made out of wafer boards before. But hey, you know, I guess physics are physics. Physics is physics. There it is. I just push that right back into that connector, and this is pretty much it. These things fit in these grooves right here, and there's screws for them on the back side here that holds them in place. I'm going to put those in last, but this thing just slides right on in this neat aluminum case. So definitely a high quality thing, you know, and it certainly seems extremely well designed. There that goes right there. Okay, and now that they're not going to flop out so much, I'm going to take the screws and I'm going to put those back in there and there. I imagine the rest of this is just going to be boring because all you're watching is for me reassemble this. So, but that gives you an idea about how this thing goes together, and a little bit about the anatomy of it, because I just found nothing. I really found nothing of this detail online of this type of power supply. So, you know, and I spent about 45 minutes searching. Now, maybe I just searched poorly because I've been known to do that. Other people say, hey, they just Google one thing, which is different than what I Google, and they find all kinds of information. So, you know, feel free to do that. Let me know if it happens in the comments. I always appreciate comments. But there we go. That plate just goes right in there with two screws, just like that. And this is a T10, a Torx T10 bit. Again, real exciting watching me assemble this, but you know, hopefully it's interesting enough. If you're still watching, thank you. Thank you for humoring me. I appreciate it. I appreciate it. And then finally, yes, I think my first clue that something was wrong was I plugged it in and this fan wasn't working. Oh, and by the way, you know, I knew I was in for an interesting journey when you know, we didn't have the usual plug like this to plug something into. Instead, I had to go with the 3 screws and just, you know, hook up the hot, neutral, and ground right there. 110 volts, so I had to be careful. So watch it. It's not for people that don't know what they're doing, because you can hurt yourself. All right, let me set this aside. So there we have what that looks like in there. This fan simply went on this jumper right here, so I'm going to reconnect that. Just like that. And that fan definitely did not go on. And I didn't even bother to check the voltage there on what that was supposed to be. But it definitely did not go on when I turned this thing on, so there we go. Fit that right back into place. I believe there's 2 more screws. Yes, there are. 1 and 2 right here. There we go. Okay, that's what that looks like. Interesting. I thought, you know, maybe something might be missing here, but no, that's just a hole for something that this is not equipped with. Initially, I thought maybe I just didn't know how to turn the thing on, because I thought there might be some pins on the backside here that I needed to connect in order to get this to work, but apparently not. Okay, I think I'm at my time limit to keep this to one video, so thanks so much for watching, and let me know what you think. Bye-bye.